Today, we're going to be talking about topic 1, which will be covering graphs. We're just going to talk about some of the key characteristics of different graphs. The first thing I want to talk about is the Cartesian coordinate plane. This is a plane with a rectangular coordinate system that associates each point in the plane with a pair of numbers. This is just our normal XY coordinate plane. If you can see those coordinates that it has plotted, it has created a rectangle with those axes. To plot a coordinate point xy, first go left or right for the x value, then go up or down for the y value. Then you can plot your point. So for the point 2, 3, first we go right 2, up 3, then you can plot the point. That's the green triangle, green rectangle. A common misconception, sometimes you hear the coordinate plane called the graph. When we're referring to the graph, we are meaning the graph of the function or the drawing on the coordinate plane, not the coordinate plane itself. At this point, you should be able to identify a coordinate on a graph a given coordinate. Quadrants. The coordinate plane has 4 quadrants. They're ordered based on trigonometry. We can determine the signs of the x and y values of a coordinate based on what quadrant it lies in. When you're looking at a graph, start in the top right quadrant, go counterclockwise to create a C. Quadrant 1 gives you positive x and positive y values. Quadrant 2 gives you negative x and positive y values. Quadrant 3 gives you negative x, negative y values. Quadrant 4 gives you positive x, negative y values. At this point, you should be able to identify which quadrant a point lies in from a graph, identify which quadrant a point lies in from a coordinate, and determine possible points in a given quadrant. Relation versus function. A relation pairs each input with an output, matches an x with a y. It's either a function or not a function. A function is always a relation. A function pairs each input with a unique output. It matches an x with exactly one y. And if you're looking at it in terms of the graph, it can pass the vertical line test. So of the 3 mappings we have below, map A has 2 x values pointing to the same y value. A function just has to match an x with exactly one y. It is okay if 2 different x's have the same y value. That is still a function. For map B, each x has its own unique y value. That is also a function. On C, Q is mapped to 2 different outputs. That one x value has 2 different y values, so that is not a function. At this point, you should be able to identify if a set of numbers is a relation or a function, identify if a graph is a relation or a function. Notation. For the rest of these pieces of graphs that we will be talking about, you want to use notation to represent them. Sometimes it's easier to use symbols to describe the different parts of graphs. So set notation is just using inequalities. Interval notation is using either parentheses or square brackets. If you're using parentheses, that means it does not equal. If you're using the square brackets, that means it is equal to. Some things to note, an infinity symbol can only be in parentheses. Since infinity is not an actual number, we can never be equal to it. So that means you can never have an infinity in a square bracket. Another thing to note is that the smaller number always goes on the left. So negative infinity is always written on the left-hand side, and any other small number is always written on the left. When we begin talking about increasing, decreasing, and positive and negative, those intervals will only be written in parentheses. You cannot use square brackets. At this point, you should be able to write set notation as interval notation, write interval notation as set notation. Domain and range. Domain is the set of x values. It's also your input, or all the values that can be plugged into the function. Domain is the independent variable, and it is the horizontal axis. Your range is your y values, or the outputs, with all the values that can be spit out of the function. Range is also your dependent variable, and is with the vertical axis. At this point, you should be able to identify domain from a set of points, table, and graph. Identify range from a set of points, table, and graph. Intercepts. We have x and y intercepts. An x-intercept is the x value when your y equals 0. A y-intercept is the y value when your x equals 0. To solve for an x-intercept, plug in 0 for y and solve. To solve for y-intercept, plug in 0 for x and solve. At this point, you should be able to identify x-intercepts from a graph and equation, identify y-intercepts from a graph and equation. You read a graph like you read a book, going from left to right. Increasing versus decreasing. So increasing intervals. So an increasing interval is the part of the graph where the y values are increasing. We want to know where at in the x values those y values were increasing. For decreasing interval, that's the part of the graph where the y values are decreasing. And again, we want to write these as intervals of x values. When is the function increasing or decreasing? So to determine where the function is increasing or decreasing, you can trace it with your pencil. Remember, starting from left, going towards the right. So if your pencil is going up, your y values are increasing, so the function is increasing. If your pencil is going down, the y values are decreasing, so the function is decreasing. At this point, you should be able to identify intervals where a function is increasing, identify intervals where a function is decreasing. Positive versus negative. Positive interval is the part of the graph where the y values are positive. Again, we want to write these as intervals of x values. Negative interval is the part of the graph where the y values are negative. So when is a function positive or negative? If the function is above the x-axis, it is positive between those x values. And if it is below the x-axis, it is negative between those x values. At this point, you should be able to identify intervals where a function is positive, identify intervals where a function is negative. Asymptotes. An asymptote is a line that a graph approaches but never crosses. And there are three main types. We have horizontal asymptotes, vertical asymptotes, and oblique asymptotes. Some functions with asymptotes include exponential, logarithmic, and rational. At this point, you should be able to identify vertical asymptotes of a graph and identify horizontal asymptotes of a graph. Drawing a graph. Using a graphing calculator or some form of graphing technology like Desmos, you can type in the function and use those graphing capabilities. If you do not have graphing technology available, you can create a table. Determine what x values you want to use, plug those x values into the function to get your y values, plot that x and y value as a point. At this point, you should be able to draw a graph using a graphing calculator and draw a graph using a table of points. I would take topic 1 quizzes to make sure you understand this material fully. If there is something that you're struggling with, which topics did you struggle with after this lesson? Please reach out to me and I can give you guys some supplemental information on those specific topics inside of this whole lesson.